Hi dear students, this class maximum time I am going to spend on properties of definite integrals. A very important idea in the chapter definite integrals. Okay, let us going to discuss first of all the properties of definite integrals. I want to discuss one particular idea because yesterday when I am discussing the last question on the definite integral as a limit of sum, some of the students they have faced a difficulty. Sir, please tell me this simplification. They have sent me in WhatsApp. Please send me this simplification. That is the particular idea. Let's continue that particular idea. Log y is equals to integral 0 to 1 log x dx we got. Then we are doing the problem on definite integral as a limit of sum. So this integration I also did there. Its integration is first function into integration of second function minus differentiation of first function integration of second function for whole integral. That's what we can write it as x log x minus x, because integration of dx is equal to x. So then we written this is equal to x into log x minus 1. There I left and I told to you people you can go further simplification here. You can do the simplification, you will get the value of log y. From that log y we can find out the y value I discussed. But there some student they expressed doubt, sir, log 0 not defined, so how to proceed? So that's why I am trying to complete the simplification. Okay, first of all, if you substitute upper limit, what happens? Log 1 value 0, that's why you will get minus 1 when we are substituting the upper limit, minus we are substituting the lower limit. You see here limits are from 0 to 1. 0 to 1 means 0 plus, that means we are substituting 0, it means limit value of that function x into log x minus 1. That is the meaning. Integral 0 to 1, upper limit I substituted minus lower limit we are substituting. Lower limit means 0 to 1 means more than 0. More than 0, that means from 0 plus onwards. Yes, logarithm is defined only for positive real numbers. So that's why you can see that further simplification we can do it as minus 1 minus, that is equals to limit x tends to 0. 0 plus means positive real numbers. Log x minus 1 divided by 1 by x. That we can write in that way. Yes or no? X written as 1 by x. Now you can see numerator not defined, log 0 not defined, denominator also not defined, not defined by not defined. We can apply L'Hospital rule or not? Come on, apply L'Hospital rule. That is equals to minus 1 minus limit x tends to 0, log x differentiation is 1 by x, denominator differentiation 1 by x differentiation is minus 1 by x square. So that's what we are getting, minus 1 minus limit x tends to 0 minus x. So that's why x is equal to 0, you will get 0. That is the reason we are getting minus 1. We got log y value as minus 1. And log y is equals to minus 1, then you will get y is equal to e power minus 1. That is nothing but 1 by e. When I discussed in the last class, objective questions based on limit as a sum, there we got this information. The question is like this: limit n tends to infinity, n factorial by n. Yes or no? N factorial whole to the power of 1 by n divided by n. This is the question. This integral, definite integral as a limit of sum, we did this particular question. The answer we left in the last class here itself, because some student they expressed a difficulty in proceeding further. That is the reason I bring back to this simplification. So we are getting the answer as 1 by e for this particular question. That is the first idea. Right, come back to the discussion on properties of definite integrals. Please note down these properties of definite integrals one by one. The first property of definite integrals. First property, integral a to b f of x dx is equals to integral a to b f of t dt. Integral a to b f of x dx is the same as integral a to b f of t dt. That means definite integral is independent of change of variable. We are changing the variable, definite integral won't be affected. That's why f of x dx or f of y dy or f of alpha d alpha or f of t dt, it won't be affected. Definite integral is independent of change of variable. How? Let us take here the substitution as x is equals to t. Whenever we are taking x is equals to t, we can take dx is equals to dt. And whenever we are taking the substitution, we have to change the limits also. Here lower limit is x is equals to a. That's why t also a. Because x is equals to a, t is equals to a. Then x is equals to b. You will get t also equal to b. Now because of this one, how this one changes? Integral a to b. In place of x we are writing t dt. That's all. So that's why integral a to b f of x dx is the same as integral a to b f of t dt. Definite integral is independent of change of variable. We can change the variable. Right. The second property I am going to discuss. This is the second property. Integral a to b f of x dx is equals to integral b to a f of x dx. Then what happens? What I did? Array integral a to b f of x dx. Here I written b to a. Limits interchanged. Whenever we are interchanging the limits, you will get a negative sign. That's all. Whenever we are interchanging the limits, you will get the negative sign. Observe here, its integration is pi of x. Limits are from a to b. Then what we will get? That we can write it as pi of b minus pi of a. Right? Now come back to the right hand side. Minus of its integration is pi of x. Limits are from b to a. Then what we will get? That is equals to upper limit pi of a minus lower limit pi of b. Now minus multiply inside. If you multiply minus inside, what happens? Pi of b minus pi of a. The same answer we got. Here also pi of b minus pi of a. There also pi of b minus pi of a. That's what. Whenever we are interchanging the limits, definite integral changes its sign. Integral a to b f of x dx. Integral a to b f of x dx. We can write it as f of x plus alpha dx. Whenever we are writing x plus alpha, how it changes in limits? We can write that one as a minus alpha, b minus alpha. At the same time, the same we can also write it as integral f of x minus alpha dx. X is replaced by x minus alpha. Then the limits changes as a plus alpha to b plus alpha. Right? Next we have, I want to discuss one particular one. Okay, I will try to prove this one. Yeah, I am taking x plus alpha is equals to t. X plus alpha is equals to t means dx is equals to dt. Whenever we are taking dx is equals to dt, what happens? When lower limit is x is equal to a minus alpha. If you put x is equal to a minus alpha, you will get t is equals to a. If you put x is equals to b minus alpha, in place of x substitute b minus alpha, then we will get t is equals to b. Now this entire integral, that entire integral changes as a minus alpha to b minus alpha changes as a to b. F of, in place of x plus alpha we have to write t. In place of dx we have to write dt. Now just we discussed definite integral as independent of change of variable. It does not depend on variable change. That's why we can change the variable here. That's why we can write integral a to b f of x dx. That's what this one. In a similar way we can prove this one. Here there is a subtraction, then for the limits there is a addition. Suppose we have another one, you can see in a similar way we can discuss integral a to b f of x dx. Integral a to b f of x dx is equals to integral f of alpha x dx. Come on, can anyone predict? We can write the limits as a by alpha to b by alpha, and extra thing is here we have to multiply with alpha. So that's why integral a to b f of x dx is equals to alpha into integral a by alpha to b by alpha f of alpha x dx. For discussion here, integral a to b, I can say this is a third property. Integral a to b f of x dx. Integral a to b f of x dx, we can write it as integral a to c f of x dx plus integral c to b f of x dx. Integral a to b f of x dx is equals to integral a to c f of x dx plus integral c to b f of x dx, where c may lie between a comma b or may not lie between a comma b. Let's participate in the discussion here. Suppose observe here, you all know this is the function. Let us say that function is f of x. This is the line x is equals to a, and this is the line x is equals to b. Now this particular portion is, I am saying the line x is equal to c. As you all are aware of that, integral a to b f of x dx. Integral a to b f of x dx means this entire area, this total area represented by integral a to b f of x dx. That's what the same thing I am discussing. This point is a comma 0, this point is b comma 0, and this point is c comma 0. Now this total area is nothing but the sum of these two areas or not, right? So that's why integral a to b f of x dx can be written as a to c f of x dx, c to b f of x dx. Sir, okay, if c is there between a comma b, is it okay? But you are saying that c may or may not lie between a comma b, you are saying, but then how it will be? Observe here, this is the discussion here. Let us say this is the curve, this is the line x is equals to a, this is the line x is equals to b, and this is the line x is equals to c. Not only left side, you can take right side also x is equal to c line. He is asking integral a to b f of x dx represent this portion, this area. The curve is y is equals to f of x. Integral a to b f of x dx. This integral represent this area, right? Now observe here what I am doing. Integral, this is x is equal to c comma 0, and next one is this is a comma 0, and next one this is b comma 0. Now observe here what I am doing. Integration c to b f of x dx. Integral c to b f of x dx. That means this total area, shaded area plus unshaded area, is represented by integral c to b f of x dx. That area is equals to integral c to a f of x dx plus integral a to b f of x dx. I hope so everyone followed. This unshaded area plus shaded area is equal to unshaded area plus shaded area. This total area is equal to sum of these two areas. That's what I written here. Now further simplification I am doing. Pay attention here. Now what we required this one. That's why this particular term shift to that side. Then what happens? Integral a to b f of x dx. Integral a to b f of x dx is equals to integral c to b f of x dx minus integral c to a f of x dx. Now I want to remove this minus sign. How to remove this minus sign? According to the second property on definite integrals, if you want to remove this sign, negative sign, interchange the limits. Come on, interchange the limits. That is equals to a to c f of x dx. First one I written this one. Remove this negative sign, written here, plus integral c to b f of x dx. There ends the matter, right? So integral a to b f of x dx, we can write from a to c, c to b. That's why whether c is there between or c is not there between a comma b. That's the reason I given, where c may lie between a comma b or c may not lie between a comma b. We can apply this particular property. Okay, so total we discussed the three properties. The first property is definite integral is independent of change of variable. The second property is if we are interchanging the limits, negative sign you will get. And the third property is this particular one. In the middle I discussed two more applications. X plus c is there, we have how to change the limits. X minus c is there, how to change the limits. X into c is there, how the limits changes. That is a discussion we did, right? So let us discuss a few problems here. So this is the first question, you can say integral 0 to pi cos x dx. Integral 0 to pi modulus of cos x dx. Integral 0 to pi modulus of cos x dx. Now we know about this modulus function. This function is positive between 0 to 90. This function is negative between 90 to 180. That's why how I am splitting, observe here. Integral 0 to pi by 2 modulus of cos x plus integral pi by 2 to pi modulus of cos x dx. So 0 to pi we are splitting at pi by 2. Okay, because the modulus function is there. Now tell me, between 0 to pi by 2, this is a positive. That's why we have to write integral 0 to pi by 2 cos x dx. Now we can do the integration of that. Whereas here pi by 2 to pi means second quadrant. Second quadrant cos is negative. That's why minus pi by 2 to pi cos x dx, right? So now we can integrate and apply the limits. There is another problem here. The problem is given in this way. Integral minus 1 to 2 modulus of x cube minus x dx. Integral minus 1 to 2 modulus of x cube minus x dx. How to proceed this particular problem? All of you observe here. X cube minus x, that we can write it as x into x minus 1 into x plus 1. We have to know about the sign conversion of this function. Now this is minus 1, next we have 0 and next we have 1, plus minus plus minus, right? So now what happens? From 1 to infinity it is a positive, and again here it is a negative. Again between minus 1 and 0 it is negative. Minus 1 to 0 it is negative. Less than minus 1 again it is negative. Between it is positive. Right. Now we have to split this one as from, observe here, minus 1 to 0. Next 0 to 1. 0 to 1. Next we are splitting from 1 to 2. So up to 2 only required for us. Now check minus 1 to 0. Observe the graph. Minus 1 to 0. This function is positive. That's why x cube minus x. Next, observe the graph. From 0 to 1, this expression is negative. That's why minus x cube minus x. Again observe, after 1, from 1 onwards, This expression is positive. That's why we have to write plus x cube minus x dx. I hope so. We can do the integration. X cube integration, you know, x power 4 by 4. Here x square by 2. Upper limit minus lower limit. We can proceed. Let's participate in another question discussion here. Integral 0 to pi by 2 secant x divided by secant x plus tan x whole to the power of 7. Integral 0 to pi by 2 secant x by secant x plus tan x whole to the power of 7. I am discussing how to proceed this question. Pay attention here. Secant x plus tan x is equals to, I am taking t, then its differentiation secant x into secant x plus tan x. I hope so everyone followed this step. Dx is equals to dt. Secant x differentiation is secant x into tan x. Tan x differentiation is secant square x. Taken secant x common, that's why we got this one. Now what I can write this one as secant x into dx is equals to secant x into dx is equals to, we can write dt by t, because this particular portion we are calling it as a t. So secant x into dx we got dt by t. Now whenever we are taking the substitution, we have to change the limits. What is the lower limit there? X is equals to 0. Whenever x is equal to 0, t is equals to 1. Next, observe the upper limit. X is equals to pi by 2. Whenever x is equals to pi by 2, secant pi t or tan 90, both are tending to infinity only. Both are tending to infinity. That's why there is sum also tending to infinity. That's why t is tending to infinity. 0 to pi by 2 changes as from 1 to infinity. So how this question changes? It changes as 1 to infinity. In place of secant x into dx we can write dt by t divided by secant x plus tan x whole to the power of 7. That is, we can write t to the power of 7. Now the problem is almost over. That is equals to 1 to infinity t power minus 8 into dt. That integration, you know, t power minus 8 plus 1 divided by minus 8 plus 1. Limits are from 1 to infinity. So that we can write further as minus 1 by 7 into 1 by t power 7. Limits are from 1 to infinity. That is equals to minus 1 by 7 into, whenever t is tending to infinity, 1 by t power 7 tending to 0. That's why 0 minus lower limit, if you substitute, you will get 1. So we are getting the answer as 1 by 7. The answer is 1 by 7. Suppose you see, next time the question is given like this. Integral 0 to pi by 2 secant x divided by secant x plus tan x whole to the power of 9 given. Then directly I can write the answer as 1 by 9. We got the answer as 1 by 7. Similarly, you will get the answer as 1 by 9. That's why simply you can note down like this. Integral 0 to pi by 2 secant x divided by secant x plus tan x whole to the power of n. We can write simply the answer as 1 by n. Okay. So let's have a discussion of another question here. So this is the question given here. Integral 0 to pi by 2 secant square x divided by secant x plus tan x secant x plus tan x whole to the power of 5 dx. So how to tackle this question? Earlier secant x is there, but now secant square x is there. Let us participate in the discussion here. Secant x plus tan x is equals to say t. Or secant x plus tan x is equals to t means what we can write that one as secant x into secant x plus tan x dx is equals to dt. Therefore, we are getting secant x into dx is equals to dt by t. Sir, it's okay. Secant x into dx we can write dt by t, but here secant square x is there, right? Yes, no issue with that. Secant x plus tan x is equal to t. Then we can write secant x minus tan x is equals to, we can write 1 by t. I hope so everyone followed, because the reason is, you know, secant square x minus tan square x is equals to 1. So we can write secant x minus tan x into secant x plus tan x is equals to 1. If you write this value is equals to t, then this value becomes 1 by t or not. So that is the idea. Then the problem is over. So how it changes? These two addition, we will get 2 times secant x is equals to t plus 1 by t. That is the idea that we are going to use. Same how the limits changes, just like as earlier, the limits changes from 1 to infinity. In place of secant x we have to write 1 by 2 into t plus 1 by t. In place of one more secant x dx, we can write dt by t divided by secant x plus tan x, we can write t. That's why t to the power of 5. Right? Now this further simplification we can do in this way. 1 by 2 into integral 1 to infinity. Right? So t square plus 1 divided by t to the power of 7 dt. T square plus 1 divided by t square t power 5. That's why. Now this further simplification we know 1 by 2 into integral 1 to infinity 1 by t power 5 plus 1 by t power 7 dt. Yes. Now that simplification is 1 by 2 into t power minus 5 integration t power minus 5 plus 1 by minus 5 plus 1 minus or plus t power minus 7 plus 1 by minus 7 plus 1. Limits are from 1 to infinity. Now further this we can write it as 1 by 2 into minus, you can take common, right? Minus 1 by 2 into 1 by 4 into t power 4 plus 1 by 7 into t power 6. Limits are from 1 to infinity. Now first of all, if you substitute upper limit, t is tending to infinity, 1 by t tends to 0 or not. That's why if you substitute the upper limit, what happens? Minus 1 by 2 into, in the case of upper limit, it becomes 0 minus. In case of lower limit, what happens? 1 by 4 plus 1 by 7. Right? Now that simplification is minus 1 by 2 into, this we can write it as minus 7 plus 1 is 6 only, na? Right, this is 6. Minus 7 plus 1 is 6. Okay, here also you get 6. So now this simplification you will get minus minus, it becomes plus 6 plus 4 divided by 24. So the answer we got it as 10 divided by, not 5 divided by 4 into 6, we got the answer, that is nothing but 5 by 24 is the answer. We got the answer as 5 by 24. Observe here what the answer we got. The answer we got as 5 divided by 5 minus 1 into 5 plus 1, we got the answer. 5 divided by 5 minus 1 into 5 plus 1. Now tell me if the question is in this form. Integral 0 to pi by 2 secant square x divided by secant x plus tan x whole to the power of 9 is there. Tell me what is the answer. The answer is, come on, the answer is 9 divided by 8 into 10. N divided by n minus 1 into n plus 1. That's why better to note down this one as a standard result. Integral 0 to pi by 2 secant square x dx divided by secant x plus tan x whole to the power of n. We can write the answer as n divided by n minus 1 into n plus 1. So that is the answer. Earlier only secant x is there. We got the answer as 1 by n. Now here secant square x is there. We got the answer as n by n minus 1 into n plus 1.